Okay, so next pattern. This one here, again, we start off with 3 generations. So generation 1, 2, and 3. We look at all the individuals that are affected, and in this case here, in every generation, you see at least one person that's being affected. Because every generation has someone that's affected, this is likely to be dominant. So every generation is affected. Therefore, dominant pattern. So the gene that we're looking for is likely to be dominant. Let's see if gender has any influence on this. So we count up the number of females. 1, 2, 3, 4. So there's 4 females. And there's only 2 males. Okay. Because there's more females than males, and this is kind of like double the amount of females than males, it's not equally 50-50. Okay, so we can most likely lean towards it being sex-linked rather than autosomal. So in the end, this inheritance pattern could be sex-linked dominant. Okay. So again, because it's sex-linked, the best thing to do is to write in the chromosomes of all the males and females. So that's what I'm going to do right now. Putting in all the chromosomes for my males and females. And we're almost done. There. All of our males and females have their chromosomes identified, their sex chromosomes. Now, because we're following a dominant gene, okay, every shaded individual is a dominant. So again, I'm going to use the same dominant that we've been using in the last few. So big R's for all the individuals that are shaded in. Now, for the females, we're going to put in just one of the big R's because we don't know what the other one is yet. But for the males, because they only have one X chromosome, by putting in the one big R, we've completed their genotypes. Okay. So let's go and look at the males that are not shaded in. The ones that are not shaded in must be the recessives. So these guys are easy too because again, they only have one sex chromosome, so they're only going to get one recessive gene. Okay, so all of them are going to be recessive, and in this case too, the females, it's easy to figure out which ones are recessive, and it's easy to write out their genotypes because all the ones that are not shaded in, if they're recessive, then they can only have 2 recessive genes. So every female that's recessive will just write in their genotypes, and that'll be it, right? So the only ones that we still have to figure out really are these 2. Well, actually these 3. Oops. Okay. Because they have a extra X chromosome, and we don't know whether or not they're homozygous dominant or heterozygous dominant. Okay, so looking at the 3, they come from parents where the male is dominant and the female is recessive. So this one's kind of obvious because the male here gives the big R to all of the daughters, but mom can only give a recessive. So the second gene on the second X chromosome, they must all be recessive. So therefore, these dominant females must be homozygous dominant. Okay. When you look at the bottom one here, okay, this is another female that needs a second allele, and when you look at her parents, in this situation you have a heterozygous mother and a recessive father. Well, she's been shaded in so that we know she carries the dominant gene. That dominant gene must be from the mom, because the dad can only give a recessive. Okay, so that second one comes from dad, and therefore this individual is also heterozygous dominant, okay, for this particular trait. So just scanning quickly to see if I missed anything. It doesn't seem like I've missed anything. So in all cases, it satisfies our rules for being dominant. It satisfies our rules for being sex-linked. There's no contradictions that we see anywhere. Everything has a very good explanation for it. So, in my opinion, this is a good inheritance pattern to show a sex-linked dominant trait.